we had some, oops, let's see if I can get to my screen here. Here we go. We had some fun last time learning about the definite integral, and we were using rectangular shapes. Now we're going to use just some geometrical shapes, and then we're going to learn about some properties that definite integrals have. Okay, so this, as you can see up here, are three shapes that you should be familiar with. So the definite integral is the area from A to B to the x-axis, okay? So this is a semicircle, as you can see, or a half a circle. And I know the formula for a half of a circle, or half of the area of a circle. It's half times pi r squared. So I could easily figure out this area. This has a radius of 2, so this would be half times pi times 2 squared, or 2 pi. So that really was very easy. That's an easy area to find out. This is a trapezoid. Remember, trapezoids have two parallel sides. And if you remember the formula for a trapezoid, it is 1/2 times the height times the two parallel bases added together. So the height of this trapezoid is, the perpendicular height would be 2 units, 1, 2. So a half of 2. And then this length, this is base 1 and this is base 2. This would be a length of 1 and this would be a length of 4. So 1 plus 4, which makes 5. So a half times 2 times 5 is just 5. So this right here has an area of 5. Now, this is a triangle. And if you should remember from geometry how to find a triangle, it's half times base times height. So the base would be this 1, 2, 3, 4 times 1/2 times the height is 2. So this makes 4. Now, here's the new thing though. When your area is under the x-axis, your position is actually negative. So you have a -4 position area. So when we go to answer these definite integrals right here, if I said, what is from 0 to 4, 0 to 4, what is the area that means of the function? Well, that would be the half a semicircle, which is 2 pi. From 4 to 8, that would be the area of the trapezoid, which is 5. And from 8 to 12, that is the upside down triangle, and that area is -4. Again, area is not negative, but its position on this graph is negative. And then let's answer this one. Well, what's the area then from 0 to 8? From 0 to 8, well, that would be both of these areas. It would be the 2 pi plus the 5. Remember, you can't combine them. It's just 2 pi plus 5. And then this one is asking, what's the area from 0 all the way to 12? So what's the total displacement here? And that would be 2 pi plus 5 plus the -4, or 2 pi plus 1. And so you can use different geometric shapes to help you out here. Now we're going to set up an integral for the following. And I'm going to highlight some areas that I want you to write an integral for. So here and then here. And then this one will be up to here. And then we'll do one more right here. We're just going to write the integrals for the shaded part of this graph. So if you notice where my bounds are, they're from -2 to 3. So that would be, my lower bound would be -2 to 3. And I would write of the function 1/9 x cubed with respect to x. That's all you have to do, just setting it up. Now this one is from -1 to 4 of my function 3/4 x squared minus 2x minus 1 with respect to x. This one is a little bit different if you notice, because I'm not going to the x-axis. I'm actually going to the y-axis. So my bounds on the y-axis are from 1 to 5. Well, if I'm going to the y-axis, then I want my answers to be in terms of solve for y, like y variables here. So what I would do to this equation right here is I would actually solve this for x so that I would have variable y variables. So I'd -1 over and then take a square root. So x equals the square root of y minus 1. And that would be the function we can use. And we're just using the positive one, not the negative side. So we can just do the positive with respect to y. Again, you will see more of that in Calc 2, but just to give you an idea. All right, now we want to sketch the graph of the definite integral and then use a calculator to evaluate. So you can plug this in your calculator, but you should know what this looks like. This is an upside down parabola. Oops, it's at 4, shifted up 4. And it would go to 2 and -2. So it'd go like that. And then if I'm bounding myself from -2 to 1, I would shade all of here up to 1. And then remember from last class to find this integral. It's in math. And then number 9, which is fn int. And you can write -2 to 1 of 4 minus x squared in the parentheses, and then respect to x. So that is an area of 9. The square root of x minus 1, so that would be here, and then we could probably go 4, 5, actually. Let's do that. Square root of 4 is 2, something like that. Now I'm only wanting to bound it from 2 to 3, so that would be this little bit right here, that little area right there. Let's find out what that area is. Oh, there we go. 2 to 3 of the square root of x minus 1. And that is about 1.2, 1.22. And then same thing here. Now this is a linear starting at -1, and then you're going up 1 over 3, up 1 over 3, or you can go down 1 over 3, 1, 2, 3. So you have this straight line. Now the area is bounded between -2 and 4, and you're going all the area to the x-axis here would be under, but then here would just be that little bit right there. And you can plug that in the calculator and I'll tell you, you get -4 as your answer. Right? Pretty easy. Now, there are properties with definite integrals. And so we're going to go through these properties. And the first one is if you have an integral from a to a where both of these are the same, then your area would be 0. You don't have any area. You can't draw a rectangle. You have a negation property that says if you go from b to a of a function, you can actually, if you factor out a negative, you can reverse those lower and upper bound limits. So now it'd be a to b. There is a property of multiplying by a constant k. So if I have an integral from a to b of k f of x dx, I can actually take that constant out and then just take the function. There is a decomposition function that says if I have an integral from a to b I can actually say, well, I can go from a to c of the function and add that to c to b. Notice a to c, c to b. These two are the same. It's the same exact decomposition. And addition and subtraction is exactly what you think if you are adding or subtracting multiple functions underneath the integrand with respect to x. Well, you can just say, oh, well, I'm just going to take the integral of f of x with respect to x, and then I'm going to take the integral of g of x. And the same would happen for subtraction. So I'm just going to put a little plus minus here. That's the same thing that'll happen. So let's do a couple of examples of this. They've given us these integrals up here. This one from -2 to 1 of the f of x is 4. From 1 to 5 of f of x is -3. And from -2 to 1 of g of x is 8. So let's find the integral from 5 to 1 of f of x. Well, I have 1 to 5. So I can flip them, I can switch them by taking out a negation. So if I put a negation in front of that, so I'd have the negative of -3 or +3. That would be my answer. From -2 to 5 of f of x. Well, if you look up here, I got -2 to 1. I've got 1 to 5. So I can just put them together, compose them together. So I can say from -2 to 1 of the function plus 1 to 5. So the area from -2 to 1 is 4, and the area from 1 to 5 was -3. So that total area must be a 1. Now this one is an addition property and a constant right there. So I'm just going to take the integral from -2 to 1 of the first one. And then this 2, I'm just going to bring outside and take the integral from -2 to 1 of g of x. So the integral from -2 to 1 of f of x is 4 plus 2 times the integral from -2 to, that's supposed to be a positive 1, of g of x is 8. So 16 plus 4 is 20. Last few, the integral from 0 to 1. Well, I don't have anything about 0 here, so that's not possible. But 1 to -2 of the f of x. Well, again, I've got the flip of that, so I'm going to not only take the 3 out, but take a -3 out so I can flip those. My lower bound -2 and my upper bound 1. And so that would be -3 times this right here is equivalent to 4. And then this one from 5 to 5, well, that's a 0 area. So these are some properties of definite integrals. Try your homework tonight.